Here we go. Exercise A, B, D, E are all the same type of skill. And it's exactly the same skill as this. Now I'm just going to find a little bit of space. You don't have to write this down. Do you know when I taught you exercise 3D? So key, if you haven't done that, should have done it already. But 3D, I showed you this. Oh, well, the way the textbook would have done it was like this. That was a turning point form. And I taught you how to read the turning point form. Let's remind ourselves. What's K do again? Hands up if you know. Anthony? Up or down. Very good. So a reminder, plus goes up, minus goes down. A. What does A do to the graph? This one's quadratic. So, quadratic could either be smiley shape or frown. So frown and smiley. When will it be a smiley shape and when will it be a frown? How do you know? Sion.
If it's negative or positive.
Good. Positive for smile, negative is frown. So the number that's multiplying to what you're squaring, so x squared, if the number in front of x squared is positive, it smiles. If it's negative, it frowns, right? And then I taught you one that I said no one else will ever teach you and you'll never find it except for my videos. What do you do to x minus h again? Let it equal to 0. So this is the only thing that I would tell you to do. Let x minus h equal to 0. Solve for x. In this case, whatever x is, if it's positive, it goes no. Right. If it's minus, it goes left. That skill you apply literally to all 4 exercises today. Everything I showed you here, we're just going to apply it differently. Now, what I want you to see is how can I tell for all the other graphs, whether you go up, down, left, right, and whether it's inverted, so it flips upside down or not. This is your original graph. Y equals x squared. That's what it originally looks like. This is what an x squared graph looks like. And all we did is if I said add something, so if you put a plus or minus, that shifts the graph. This is your shape. It goes up or down. Then the number in front of this function, so the number in front dictates whether it's thin, wide, or it's flipped upside down. Yeah, so if it's negative, it flips the graph. If it's positive, it stays the same, right? So you just need to know the shape of the graph. And in these 4 exercises, you've got 4 different graphs. So if it's positive, it stays the same shape. If it's negative, you just flip it vertically, okay? Then this is the only part that you have to think about. That's the only part in all 4 exercises that you need to be able to observe. So where did this x minus h come from? It's replacing that x. It's what you're doing to that x variable that determines left or right, because it's your x-axis. Okay, so it's your x-axis. Horizontal movement is affected by what you do to every single x value of your function. So what I'm going to show you today, and I'm going to do Desmos so you can see the pattern here. I'm going to go to Desmos just so you can visualize what's happening. Here's your y equals x squared graph, right? All I do is I taught you in exercise 3D was to learn what we call transformations. Now, I haven't taught you transformations yet, so you're memorizing this, okay? When I type the same equation again, but I put a plus 1, you can see that the blue graph has gone up by 1. If I do plus 2, it goes up by 2, 3, 4. So you can see at 4, turning point has gone up, right? If I then go minus 1, minus 2, minus 3, minus 4, oh, sorry, minus 4, goes down by 4. So very logical. Now this is exactly the same, even if I used a different graph. So exercise 4A. What is 4A? This is your graph. I'm going to change the graph now. The first graph that you're going to learn is called a rectangular hyperbole. So I'm going to take it away. This is what a rectangular hyperbole looks like. So on your notes, let's go back to your notes now. You just need to know the shape. This is a rectangular hyperbola. Okay? This function is the result of doing 1 divided by x. You just need to know the shape first. Now, applying what I taught you in exercise 3D, whatever you add to this function, because that's the shape, whatever you add or subtract to the function will shift this graph up and down. Okay, so let's have a look. I go back here. I do exactly the same that we just did with our quadratics. So 1 over x, it's in blue. Now all I do is I say plus 1. Can you see how it shifts the graph up 1? Plus 2. Whoops. Plus 2. Plus 3. Plus 4. Now what's interesting is there is an invisible line that we can't see here. There's a name for it. It's a special name, and that's what each exercise has. They have a property. Rectangular hyperboles have this invisible horizontal line that it never touches. Out of curiosity, anyone know what the name of that invisible line is called, starting with A? Asymptote. So for those who don't know, asymptote, I'm going to write in your notes here. There is a horizontal line, so fill this in your notes and use a ruler. Normally that's how you're meant to do it. You're meant to use a ruler with a dotted line. There is a horizontal line at y equals 0 that the graph never touches. It gets really close, but it never touches. If it never touches it, but it gets really close to it, we call that an asymptote. Let's have a look at the graph. I'm going to zoom in so you can see. I'm going to take off the blue graph. See this? It looks like it's going to touch the x-axis, but if I keep zooming in, there's always a gap. See over there? It keeps getting smaller and smaller. I keep going all the way across. I keep coming in, and it's always got a gap. Never touches the x-axis. It gets very close. Now, why is that? Let's think about it mathematically. 1 divided by a number. Let's go 1 divided by 2. What do you get? 0.5. Okay, let's do it again. What's 1 over 3? Decimal wise? 0.333. Yeah. What's 1 over 4? 0.25. What's 1 over 10? So I'm increasing the denominator. I'm making it 10 now. So 2, 3, 4, 10. What does it become? 0.1. What's happening to the numbers? It's shrinking. But can you give me a number? 1 divided by what? Will give you 0. Because if you want to find the x-axis intercept, you always tell me it's when y equals 0, right? So 1 divided by what will give you 0? A lot of students will say 1 divided by 0. What's the problem with 1 divided by 0? 1 divide 0. What's the answer? Undefined. Because you can't. You can do 0 divided by 1, but you can't do 1 divided by 0. So how do you get y equals to 0? You can't. It's impossible. That is why if you keep increasing the denominator, so in that fraction, I'm just going to press home. The reason why, no matter which way you go, if you increase the number 2, 4, 6, 8, 10, you already just told me it went from 0.5 to 0.33 to 0.25 to 0.1, and then it gets smaller. It gets infinitely small, but it never reaches 0. So that's what we call an asymptote. What's interesting is you can also see here, in this direction, when it goes up, when it's closer to 0, there is also another asymptote. And that asymptote is a vertical line. Can you draw in your notes now? So exercise, this is your notes. Let's draw it in. You've got another vertical line that does the same. And this line, this vertical line, is an asymptote at x equals to 0. These are called asymptotes. This is a horizontal asymptote for y equals 0, and this is called a vertical asymptote. When you're sketching these graphs, this is a key property. Kind of like quadratics, your key property is a turning point. A key property for any fractional function. So on 1 on x, as soon as you've got a fraction, the problem is you can't ever divide a 0. That's why when x equals 0, there is no solution. And the same thing, you can never think of a number on the x-axis to get y equals 0. That's why there's 2 sections that it has invisible lines. Why am I talking about these invisible lines? Because that's how you're going to draw your graph. So exercise 4A and 4B, they're both fractional graphs. See that? They have this little asymptote. They get really small. What's the second graph? This is exercise 4B. This is called a truncus function. And I want you to write in, this is what the function looks like. 1 on x squared. Looks like a tree trunk. Easy to remember. Why does it look like a tree trunk? Because every time you square a number, you'll never have a negative y value. It's impossible to get a negative y value. So that's why there's nothing on the bottom. Here, you can have a negative y value. 1 divided by negative 1 will give you a negative 1 value. That's why the graph can have a bottom half. This one can't. But they both share one very similar thing. They both have asymptotes. Yeah, because you can't ever do 1 divided by 0. If you can't do 1 divided by 0, so x equals 0 does not have a solution. And you can never do 1 divided by a number that will get you y equals 0. So they both have a asymptote. So right here, y equals 0 asymptote. And they also have x equals 0 asymptote. Now let's just work it with A and B so that you get a feel of this, okay? So what you learned in quadratics, exercise 3D, up, down, left, right, flipping, you do exactly the same for these graphs. I'll show you. As you're copying these notes, just make sure these are your key features. So when you're sketching it, you always have to have vertical and horizontal asymptotes. Must be labeled. If you don't label it, you lose a mark, right? Graphs, when you draw them, asymptote specifically, when you draw it close to the line, don't touch the line, and 2, don't curve it up. If the line kind of shows that it curves up, you lose a mark. Okay, so the examiners always look for, does it actually approach towards the line and doesn't actually curve back? It never curves up. It gets smaller and smaller. Yeah? Let's have a look at the actual Desmos now. I'm going to show you something cool. So, I'm going to write them all. So, y equals x squared. That's one graph. You've seen that before. You're learning in exercise 4a, 1 divided by x, so that's a hyperbole. You're also learning 4b, 1 on x squared, right? All 3 graphs. Sounds really hard. It's not. Which one I'm going to do? I'm going to now write them all in terms of plus k. Now, you told me k goes up and down, yeah? So watch this. I do plus k. Okay, it says add a slider. So I'm like, all right, I'll add a slider. But let's do a plus k to the hyperbole. And let's do a plus k to the truncus. If I press play on k, means that I change the k value. If k is 1, every graph shifts up by 1. If k is 2, everything goes up by 2. You'll see that all the graphs do the same thing. So if I press play, look at that. Oh. Can you see that the function I taught you in quadratics in 3D, if you knew how to do 3D, you can do all this. All you needed to know was what's the shape of each one. If you know what the shape is, you just put a plus k, everything goes up and down. See that? So if k is 6, 5, 3, 2, 1, negative, it goes down. And then it gets plus, positive, positive, 0, 1, it goes all the way up. So when you're sketching, if I asked you to sketch this graph here, let's go to exercise 4a just so you get a feel of it. Where's 4a? Oh, 4a is not here. Where's 4a? 4a. I want you to look at this example. It looks scary, but it's not. Let's read it. Which one of these graphs shift up or down in question 1? Tell me which ones go up or down. E does. E has a plus 2, so yes, E goes up by 2. So if I were to sketch this, this is what it looks like. Y, X, if it shifts up, that means my horizontal line has to go up by 2, and the graph is still the same. It still looks like this. Can you see that? The line was here, and I shifted up by 2, so of course the horizontal line goes up, but the vertical line stays the same. That horizontal line I set up by 2, so everything goes up by 2. Just like that. Cool? That's that graph. Give me another one. Which one goes up or down? Which ones can you see? F goes down. Very good. F is down by 3. So if I were to sketch that, down by 3, horizontal asymptote is y equals negative 3, and the graph must be like this. Same thing. Obviously, you have to draw it more properly, but I'm giving you an idea. Yeah? So if you can read what you did in quadratics, you can do it the same for these ones. This one goes up by 2. This one goes down by 3. This one goes up by 5. This one goes down by 4. This one goes up by 3. This goes down by 4. See what I'm teaching you? You can do that for exercise 4b. So let's go 4b. Which ones go up and down? Down 4. Up 1. Down 4. Up 3. Down 6. Up 2. Can you see what I'm doing? And they're only different because the type of function. It's a 1 on something squared, so it's a truncus. The other one, 4a, is not a truncus, doesn't have a square. So this is a hyperbole. Get me? So your skill in chapter 4 is identifying what type of functions do you have, and then you read up, down, left, right, and then inversion. Yeah, so let's go. I'm going to go now, change k. I'm going to do k, so we've learnt k. Remember, what did I say that a does again? What does the number in front of a squared do? smiley face, or it gets thin, wide, and it flips. Yeah, so frown or smiley. So, watch what happens when I add an A as a slider, and I'm just going to move, yeah. So everything, I'm just going to bring K back to 0. So this is your original graph for all of them, yeah? Watch what happens when I press play on A. Same thing. It might be a bit crazy and confusing here, but just watch what happens. Oh, sorry, I didn't put A on the other ones. I should do A times, and then this one should also be A times. Can you see that all I did, they all do the same thing. As this gets thin, they all get thin. This gets wide, they all get wide. It's the same thing, because A, if it's positive, it stays the same shape. If it's negative, it flips. Everything flips. See, the green one flips, the black one just flips. So I'll show you slowly. Let's do it. Let's take off the green, let's take off the black. Here's hyperbole. Watch what happens when I press A again. You see that? When I increase, everything just gets stretched out, and then what you see is it flips. That's when it's negative. See negative? It just flips. So what's over here flips over here, what's over here flips over there. That's why it changes sides. Make sense? Which one? The reflection is a vertical reflection, which is over the x-axis. Yeah. So I haven't talked about transformations yet, so for now, just think of it as whatever's on the top flips to the bottom, whatever's on the bottom flips to the top. Just kind of like a quadratics. Whatever's on top goes to the bottom. Yeah? It's easier to see with a truncus. Watch what happens when I put back in the truncus. You'll see the truncus one. So that's negative. A is negative. Positive. It's upright. Negative. Flips down. Just like a quadratic. But that's what A does. I'm just putting A in front of the function. So as long as you know what the function is, anything you multiply to it is exactly what you did with quadratics for A. So smiley face frown, then wide. K, up, down. But the left, right is always what you deal with the x's. Okay, so you have to look at where the x's are. So that's where the x is. That's where the x is. That's where the x is. What I taught you is if you let it equal to 0 and then solve it, you find that it flips the other way around. So it goes, if it's positive, it goes to the right. If it's negative, it goes to the left. Yeah, so watch this. So now I'm going to change them all. I'm going to change this back to 1. So back to all the original graphs. So here's all my original graphs. And let's do the turning point form. So remember, what am I squaring? It's the x. Now if I change that x, if I said do plus b, okay, I do a plus b, and that's what I'm changing to the x for all of them. Every one of them I'm going to do the same. Instead of 1 divided by x, it's going to be 1 divided by x plus b. Instead of 1 divided by x squared, it's going to be 1 divided by x plus b squared. See that? So I'm just changing them all. So here, let's do this now. I'm going to change this to plus b. And then down here, I'm going to do the same. It's x plus b. And you will see that when I add in the slider, whatever I do to b, they all do the same. Doesn't matter which graph. You can type in a sine x function, it's the same thing. If I type in sine of x and I did exactly the same thing, a, b, and c, okay, they will all shift the same way. So when it's negative, it's gone to the right. When it's positive, it's gone to the left. But don't memorize it because of the signs. Memorize the way I taught you. Let what you have in x, let that equal to 0, and then solve it. That's the way I taught you guys, yeah? So let's go back to your notes. Let's go back to your notes here. See this? Which ones move left or right? Which ones move left or right? Name me the letters. Bottom right? Yes, this one has a movement. And the way I taught you is wherever the x is, let that equal to 0 and then solve for x. Now x minus 3, if you let that equal to 0 and solve for x, x should equal to 3. So it's positive 3, so it means it moves to the right by 3. So if I ask you to sketch this graph right now, this is how easy it is. Here's my axes. It's gone down by 4. So down 4. You told me right by 3, because if you solve for x minus 3, x equals 3. So it moves to the right by 3. That's your new asymptote, because you shifted the graph to the right, then you shifted it down. So obviously the horizontal line is down. This is your new axis. Don't forget there's a negative. What happens when it's negative? What happens to the graph? It flips. Yeah, so originally it was like this. But if you flip it, it should now be whatever's on the bottom goes to the top, whatever's on the top goes to the bottom. Roughly like that. What am I missing? I don't have an x and a y-intercept, which you have to calculate. Okay? But in general, you should all be able to get key features, asymptote, and the shape of the graph. That's 2 marks already. Your third mark comes from finding axis-intercepts, which is you either let x equal to 0 or you let y equal to 0 and solve. Okay, and this is then back to chapter 1. How are you with fractional equations and solving for x? Yeah? We'll do that later, but just so far, how's it feel? Does it feel very similar to exercise 3D? Yeah, so that's why you can do 4A, 4B, 4D, all the same, because they just tell you what graph it is, and you just learn left, right, up, down. Yeah? So, let's have a look at 4B. This is a truncus function. How did I know? I see the square in the denominator. These are all truncus. Down 4, up 2, down 6, up 3. Which ones move left and right? Go, tell me the letters. Tell me one letter. Adi, which one goes left and right? Or left or right? Which one has a horizontal movement? A does, because that's a plus 3. Plus 3 tells me what, Numafi, left or right? Left. This is left 3. Next one. What's another one with their left or right movement? Let's go with Lillian. Do you see a left or right movement? Which one? C. Very good. Again, it's what you're dealing with the x. It's that x minus 2. That's what you're doing. So the x minus 2, Lucky. Oh, so Lucky's not here. Ben. Moving left or right? X minus 2. Right 2. If you solve for that, that should be right to the 2. It's positive 2, so right by 2. Let's go with the next one. What's another one that moves left or right? Let's go with Milena. D. D has the x minus 1. That tells me it moves left or right. Is it left or right, Bete? Right. Right by 1. So if I asked you to sketch these graphs now, let's just do D as an example. We know it's a truncus shape, so it has to look like a tree trunk. We know that it moves up by 3, so here we go, up by 3. That's my new horizontal asymptote. Vertical asymptote, you move to the right by 1, like Mete said. So here we go, x equals 1. And it's a truncus. Clearly from the graph I know there's no x-intercept, so you don't have to worry about finding x-intercept. You're just going to find y-intercept. How do you find y-intercept? Let x equal to 0. So it'll be 1 divided by 1 plus 3, so it must be 4. Okay? You see how I'm doing it? I'm just using what you've learned in exercise 3D, but you can apply it to all functions. So whatever I haven't taught you, on your notes sheet, let's go back to your notes now. I'm going to give you all the general shapes so that you technically, in one session, know how to read them all. So here we go. So you got the first one, 1 on x, rectangular hyperbole. Second one, truncus, this is 4b. Truncus, 1 on x squared. Next one, square root function. This is what it looks like. That's the shape, starts at the origin. It's kind of like a sine-on parabola. Think of it as like a side-on parabola. Yeah, it's like a side-on U. And I want you to write the equation for this one is y equals 2 square root of x. Fill that in. Should be root of x. And watch this. I'm going to put all 4 functions up. Oh, this is still moving. Look at that. So funny. Here we go. I'm going to put in the square root function now. Y equals square root of x. Now, if I wanted to move up or down, plus k. If I wanted to have a inverted shape, up or down, so a times the function. And then if I want to move left or right, it's what you do with the x value. It's not the function. It's not the square root. Boys, it's not the square root. It's what you're square rooting. So here, if I just said plus b. I'll change the color so that you can see the difference between all of them. Let's change that to red. Watch what happens now. I'll press B. Can you see how they all do the same thing? That's your square root function. And that's 4D. It's pretty straightforward. For A, B, C, D, you can learn in just this one session because you've done it in your quadratics. If you know how to read your quadratics left, right, up, down, you can do it all for the shapes. If I did up, down, let's go the K's. I press K. So now it's just up, down, left, right. Just going up and down, left, right. They all do the same thing. That's why you only just need to know the shape the function, so if you can identify it, you can just read the transformation. I haven't taught you why this works. I'm just teaching you to memorize it. Yeah? And then obviously we add in A as well. It gets very crazy. It goes like thin, wide. So if I then add A, there we go. Gets thin, gets wider, then it flips over. It's all the same. Now, what I like, the one that's most exciting is probably, in my mind, is the square root function. It's the best way to see what's actually happening. So if I just move B back to 0, so we start at the center, K back at the center. That's what happens when you change A, which is the number that's multiplying to the square root function. See, it's negative goes down, positive goes up. But the larger the number, the more stretch it goes vertically. Technically, the technical name for it is a dilation, means a stretch. It's a vertical stretch. Okay, so every time you put a number in front of a function, what you're actually doing is you're stretching it vertically. That's why they get really wide, upwards. That's why a quadratic looks really thin, okay, because you're pulling it vertically, essentially. So that's what's happening here. So what I just taught you in a very short span, which we can spend another session on, we have a whole week and a half to learn this, which is really straightforward. You just learn the transformations, know the graphs to label, and you just find out the key features. Because, that's a good question. It gets really deep, but just to give you an overview, you know how you got y equals x squared? What's the inverse of squaring? Square rooting. But remember when you square root, let's say square root of 9, what is it equal to? No, just 3. The graph is called a square root function. I haven't taught you what a function is, but technically what it's actually missing is, I'm just going to delete all this so that you don't get confused now. When you do a square root function, it should actually be like this. That's the positive part, and there should be a negative part. Can you see how this shape is actually just like a quadratic? The quadratic's like this, and then the square root is that. This is called inverse functions, which I haven't taught you guys yet, but I haven't taught you what function is. So the reason why you only do the positive, the top half, is because that's considered a function. This together is not a function, it's called a relation. So this is called a square root relation. It is the inverse of x squared. But don't worry about that, we'll get to that point. But just to answer your question there, it's because this is a function, these two together is not, but that's what a square root relation looks like. Okay, it's like a quadratic, but just on the side. Okay? So today's lesson, all I wanted you to understand at a very bare minimum, don't worry about circles yet, I just want you to be able to read the transformation. So revising your 3D, so if you didn't get it then, hopefully now you're starting to feel a bit more confident with it too. But just looking at 4A, 4B, and 4D, you should be able to look at each one of these exercises. So if I picked 4C, for example, you should be able to look at it and then just tell me which one of those, oh, is that C? No, where's D? Ah, it's D, yeah. You should be able to look at this and tell me which ones move left, right, up, and down. You should be able to visualize what it should look like. That's the goal. The goal is that I can give you something like this, and in your mind, you should be picturing something like this. Down by 3. So down by 3. So start off the center, down by 3. Left by 2. So it goes to left, left over 2. So down by 3, left by 2. And then, that's a positive shape. There's no negatives. So it should look something like that. I just don't know where the x and y intercepts are. It could be over here, it could be over there, I don't know. Okay, but you should have the shape. So you have the key point, starting point, axis intercepts, and shape. That's 3 marks. And I just did that, and that's 4D. That's why I'm saying that all those 4 exercises you can do very quickly once you understand how to read the transformations. Cool? All right, so I'm going to pause there. That's just that for today. But in your notes, I've got some practice for you. So I'm going to give you, it's currently 12:49. Let's make it 10 minutes. I want you to go to your notes now. I gave you a couple of functions. Can you have a go at sketching? Oh, wait, did I not give you a sketching? Oh, it's over here. I want you to, in the next session, I'll fill out the other stuff. So circles and all that. But right now, example 1, example 2, and yeah, that should be enough. Wait, oh no, there's example 3 and example, don't do 4. I haven't taught you circles and half circles yet. You should be able to do 1, 2, and 3. I'm going to pause the video. You got 10 minutes. And then we're going to look at the answers together. And then you can have your time to figure out which exercise you want to work on.